Hello and welcome to Vaughan Public Library's online 3D design course. Today we will be showing you how you can use free online resources to design and edit your own 3D files, which you can later print using one of Vaughan Public Library's 3D printers. Now let's get started. Today we'll go over how to design a unique item in TinkerCAD and then how to further edit and enhance that item using free software called Meshmixer. Lastly, we'll highlight some free resources for further training. TinkerCAD is an online computer-aided design software created by a company known as Autodesk, who creates all sorts of professional-grade design tools for all sectors of media and production. TinkerCAD is their educational tool aimed at introducing computer-aided design software to people of all ages and skill levels, and can be used to create 3D objects and electrical circuits. Since TinkerCAD is web-based, that means you can use just about any device to access it, such as a Windows PC or laptop, a Mac, a tablet, or even your phone. Though do be aware that the touch-based controls are still early in development and can be more difficult to use than traditional keyboard and mouse. At its core, TinkerCAD uses an interface that works like many paint and art software that many of you may be familiar with. This allows users to place and interact with objects selected from a palette of pre-designed 3D shapes to create something new. Once the object is placed onto the workspace, users will be able to move and adjust the sizes of the objects to create whatever they can imagine. Once their 3D designs are complete, they can be viewed in either the standard 3D form, as a Lego design, or as a Minecraft map. They can then convert these 3D objects into Lego or Minecraft shapes, or export the 3D objects as a 3D printable file known as an STL. All users of TinkerCAD must create an account with an active email address. It is important to be aware that there are two types of TinkerCAD accounts, a children's account and a parent or adult account. If the user signing up for an account is under 18, they will be signing up for a children's account. This account requires the approval of an account held by an adult over 18 before it can be used, and this approval process can take up to a few days. There is a way to fast-track this, however, it requires the payment of a small fee. In this section, we will go over the interface of TinkerCAD and give you a good idea of how to navigate the workspace and how to access your work. This is the main dashboard you will be welcomed with once you sign in to your TinkerCAD account. This will list all of the projects you have worked on previously and will give you access to the various blogs and web pages that you can reference to help you along your 3D design journey. Let's break the main dashboard page into 4 different sections. Section 1, the page navigation bar, has several tabs for you to click on to navigate to other sections of the TinkerCAD website. If you click on the TinkerCAD logo in the top left, it will always return you to this dashboard web page, so it will serve as the home button. The gallery button will take you to a large collection of recently created 3D objects from other TinkerCAD users. Learn will take you to a page with several different tutorials, and the Teach button goes over several features that TinkerCAD offers educators, such as teachers, parents, or librarians, on how to share the wonder of designing in 3D. Section 2, the User Profile, has 2 access points. The User Profile button on the top right-hand corner of the screen will take you to an area where you can switch over to another user's account, log out of the current account, or make changes to the account itself. Section 3 is the Projects tab. Here you can organize your designs into different projects so you can keep multiple designs grouped together. Lastly, Section 4 is the Recent Designs area. You can see a list of the most recent designs created in TinkerCAD. These will be listed from the most recent to the oldest. You will also see the Create New Design button in this area, which is where you will click to begin a new file. Once you click on a file to continue working on, or have selected the Create New Design button, TinkerCAD will load up the workspace for you to use. This is the TinkerCAD workspace, and where you will use a set of pre-rendered shapes to create your 3D designs. To better organize and break down the work area, let's split the screen into 5 different areas and explain what each of the icons do. Section 1. At the very top of the screen, we have the upper toolbar, which holds the tools to save your work, rename your file, log out of your account, and return to the main menu. Below that is the lower toolbar, Section 2. This contains the editing tools such as copy, paste, duplicate, as well as the alignment tools and the options to import files and export your work to share it with others. The View tools are located on the left-hand side of the screen, Section 3. Here are the tools that will help you get a 360-degree view of your work, as well as zoom in and out. On the right-hand side of the screen is the Palette, Section 4. Here is where you'll find the shapes and objects you'll be manipulating on the work plane to create your projects. The last piece is the main work area itself, known as the work plane. Only objects placed on the blue grid are considered part of the project. If you export your project with 3D objects that are not on the blue grid or attached to it in some way, they will not be exported. In this next section, we will go over how to place and manipulate objects on your work plane in order to create several different shapes. We will also demonstrate a few exercises to better explore these concepts and show you how the tools and techniques work. Placing objects onto the work plane is as simple as dragging and dropping. From your palette on the right-hand side, click on a pre-constructed shape and drag it onto the work plane. In this palette, there are two main categories of objects, solids and holds. Solids indicate an object that will be filled with material when it prints, and a hole, which is a grayed out shape, signifies the absence of material. To make the cube hollow in the middle, let's simply drag a cylinder hole and place it in the middle of the cube. And there you've created the absence of material. When designing objects in 3D, it is very important to be able to view your creation from different angles. Sometimes when an object looks perfect from one angle, it could be drastically off on another. There are two main ways of changing your viewpoint of the work plane on your project. The first is by using the view cube on the top left corner here. If you click on various sides of the cube, it'll take you to that view. The second method of controlling your view is with the right click. If you right click on the work plane and hold it and drag the cursor around, it will give you free control over your view. You can zoom in and out of your project using the plus and minus signs on the left-hand side in the toolbar. If your mouse has a scroll wheel, you can zoom in and out of your project using that as well. You should make regular use of these tools to get a close-up angle of your design to make sure that everything is properly attached. By zooming in, we can actually see that there's a tiny bit of space between the two objects. Rotating your objects works pretty easily once you get the hang of it. After selecting the object by clicking on it, you will notice several white and black boxes appear in and around the object. You will also see several arrows. These arrows allow us to rotate the object along the X, Y, and Z axis. You can do this by clicking on one of these arrows and dragging your mouse up and down to see it rotate. Don't forget about your undo button up there. You can also click on one of the arrows and enter the numerical value right here. You can also stretch and adjust the size of your object, making it wider, thinner, taller, or thicker for whatever your project requires. Just like before when you were rotating an object, you need to first select the object that you want to change by clicking on it. Again, you'll see the white and black boxes appear. By clicking and dragging one of the white boxes, you will change the length and the width of the item. You can affect the length or width separately by using the black boxes. There is a special white box located on top of the object. This connects to the bottom of the object with the thin dotted line. This white box is the tool we will use to adjust how tall or short we want the object to be. If you need to be very precise with the size of your object, select one of the boxes and type it in manually. The default measurement here is millimeters. Grouping refers to combining multiple objects together to create one. This means that any change you make to one object will affect the other. For example, moving it on the work plane or changing the size or rotation. This can save you a lot of time in the design process. To group your objects, place them in the desired position, highlight them, and then click on the group symbol right here. Now, these two shapes have become one shape, and appear in one solid color. If you change your mind, highlight and click on the ungroup icon. TinkerCAD is an online software tool that uses storage known as the cloud, and every time you make a change to your file, those changes are saved and sent to the cloud for storage. So no need to click on save every time you edit. Being saved in the cloud does not mean that it's ready for a 3D printer though. To export your TinkerCAD design for 3D printing, select the Export button on the top right toolbar, and you'll be presented with a few options. You can either select to print everything in the design, which means everything that's sitting on the work plane, or just a single selected shape. For the file type, if you're printing at VPL, always click on .stl, as that's the file format we print with. Now your file is ready for Slicer software. Next, let's learn how you could further edit and customize your 3D item using a free tool called Meshmixer. This is the Meshmixer interface. The tools are on the left-hand toolbar, and the work plane is where you'll be editing your design, and that will appear in the center once we have something to work on. The tools that we are going to focus on today are the Edit, Sculpt, and Export tools. But first we have to import an item. After you open Meshmixer, click on Import and select the desired item. Now this raw 3D scan does not look very good, but don't worry, with just a few basic edits we'll have it looking printer ready. And you'll notice that it's sitting below the work plane, so one of the first things we have to do is to bring it up, and that's how you'll use your Transform tool. So click Edit, and then click Transform, and you'll notice a series of arrows and a circle. Click on the green arrow and drag it above the work plane. To rotate it, we're going to click on this red curved line, click and drag until it's reached our desired position. We're going to aim for about 90 degrees. Once it's set, click on Accept. Just as an example, let's click on the other arrows to see how it changes the design and how it sits on the work plane. Again, I'm going to click on Transform, click on the green arrow, which moves it back and forth. The blue will bring it below the work plane, and red left and right. The next tool we are going to use within the Edit toolbar is the Plane Cut. This will be a great tool to use to split 3D files into multiple parts if you need to do so for printing. For example, if your item is too large for one single print job. What we'll use it for here is to give the bottom of the scan a fresh, even, and straight cut. So let's first click on the Edit toolbar and then Plane Cut. Here's where you will get to decide exactly where to cut your item by moving the blue arrow up or down, which moves the grid. Whatever is below the grid will be removed from the design. Once it reaches the desired position, click Accept. Now you can make a plane cut on any axis and on any angle that you wish. As an example, let's try to cut this scan down the middle. So again, we'll click on Edit and then Plane Cut, and instead of the blue arrow, we are going to click on this red curved line to change the rotation. We're going to aim for about 90 degrees. And once we reach the desired position, unclick and press Accept. Now this doesn't do anything for our design, so I'm going to click on Actions at the top and click on our handy Undo button. A very useful tool when editing a 3D scan is the Make Solid tool. Because 3D scans rarely come out perfectly, any gaps that the scanner didn't pick up can be later filled in. Let me zoom into the design so you can see what I mean by a gap. You can see right here. To fix this, I'm going to click on Edit and then Make Solid. And here we'll wait. If you have a job that has a lot of holes and gaps, this may take a couple minutes, but this design was pretty good. Now you'll notice that this hole has been filled in, so I'm going to click on Accept. Next, let's talk about sculpting brushes. Meshmixer has a variety of brush tools that can really help customize your item. I find it very helpful when editing 3D scans, particularly for hair, because hair is always difficult for a 3D scanner to pick up. Click on Sculpt, and then click on Brushes, and you'll see a wide range of brushes that pinch, shrink, flatten, or drag out the file. So I'm going to click on Drag, and I'm going to move my brush down there however I like to fix how the hair is looking. You'll also notice that you could pick the strength and size of your brush to get very detailed. There is so much more you can do to files on Meshmixer, but I'm pretty happy with how this scan turned out, so I'm going to print it. To prepare it properly for a 3D printer, you have to click on Export. Here, make sure that you select the proper format for Vaughan Public Libraries, which is .stl. That way our printer software can read it. We recommend using these free resources for further learning. TinkerCAD offers great tutorials that get really in-depth because we only really covered the basics today. They also have a help center to help you with your unique issues. If you'd like to get better at using Meshmixer and editing your designs, lynda.com, which is available free from the library's website, has a Meshmixer essential training that goes over every function. You can also use the Vaughan Public Library 3D certification course for further learning. In the transcript of this course, we've included clickable links to all of these resources. Thank you for taking Vaughan Public Library's online 3D design course. We hope you enjoyed it.